Another example of hypothesis testing, both using the hypothesis testing methods and how do we make decision by using confidence intervals. So here I'm going to show this example one more time to give you an exposure as to how we are going to make a decisions on certain problem using both the confidence intervals methods and by using hypothesis testing. In this case, we are going to explore the T distribution. Right? Okay, let's get going. All right. Okay. Now I'm going to read through that one more time for those who are new to this. Now, a bus company is about to start a scheduled service between two towns some distance apart. Now, before deciding on an appropriate timetable, they are going to run nine trials, right, to see how long is the journey it's going to take to traverse between those two towns. The times recorded are as given there. So the first data collected was 89, then second one is 92, third one 95, 94, 88, 90, 92, 93, and 91. Right? Now the first question, use this data that they have collected to set up a 95% confidence interval for the average journey time traveling between those two towns. Now you should assume that the journey times are normally distributed. Yes. Okay. Because the sample size is quite small, so if you don't want to, if you don't make these assumptions that the distribution is normally distributed, then we will have to use another methods for this analysis, which is called the non-parametrics that we will be doing on another separate video. Right? Now, the second section, the company regards its main competition as the railway service, which takes around 95 minutes here. So, does your confidence intervals that we have obtained from the section 1 provide evidence that the journey time by the bus is different from that by the train itself? Okay, now we'll look at whether that is true or not by using these two methods, the confidence interval methods, and by using the normal hypothesis testing method. Right. Now, first method using confidence interval. Right. Now I'm going to write it down here. Make decision using confidence intervals method. So method number 1. Okay. Now, before we can work out the 95% confidence intervals, now there are a few informations or the data statistics that we need to lay out first before we can work out the confidence intervals. So first of all, we have the sample size. So for this statistics, for this sample, we have the sample size is equal to 9 because 9 trials has been conducted, and then these are all the data that we collected. So first step is we have to calculate the average time taken for the journey between those two towns. So now the average is given by this divided by n here, and then you can actually sum up all this data that we have collected, and then that would actually yield, I have already calculated here for ease of reference here, we will get 91.6 approximately if you leave your answer to the nearest 3 significance. Of course, in reality, the more decimal places there are, the better the accuracy. Right? Now, the second information that we need will be the sample standard deviation. So the sample standard deviation is given by this definition here. Now, because this is a sample standard deviation, therefore we are applying this unbiased estimator, which is divided by n minus 1 here. And then by by computing all these results here, we should be able to obtain 2 point, I would say 297, 297. Maybe I put it to the more higher accuracy standard deviation. Of course, some of you may like to leave the answer approximately as 2.30. That is fine. Right? So I hope that is clear. We can use this formula to tabulate the sample standard deviation. Now, of course, as a review, you can also apply. Oh yeah, I almost forgot. Whenever we apply standard deviations, there is always a square root. Yeah, this is the part that I always miss out. Now, there are a few versions of this formula that you can use. Okay, you can also use this one. If you actually expand this and then manipulate it algebraically, we will end up to some other format of standard deviation in this form, or you could use the other one here, which was suggested by Yun Jae, if I'm not mistaken. And News have already checked through this. Right? Thank you very much for all your checking all this while. Right? Now let me see whether I still remember what we have here. I think it should be sigma divided by n minus 1 here. Alright, so these are the few versions of standard deviations for the sample that we can use depending on how comfortable you are in computing this result. So either way, either one of these three formats will yield the same result, which is approximately 2.297 or 2.3 here. So I hope that will be useful to you. Now, once we have obtained this, the first question was quite easy to obtain. We're going to calculate the 95% confidence interval here. Right, now the formula for 95% confidence interval is here. So that's CI. Confidence interval for 95% here is given as such. So that confidence interval is plus or minus. And then now for this problem here, we are not given the population standard deviation. So here I'll write down this information is unknown. Now because it is unknown, by the way, the sample size is just too small. So it's better not to use the standard normal distribution, even though we can assume that it's normally distributed. Preferable, we are going to use the T distribution or student T distributions here. That is given by the critical value from the student T distributions related to 95% confidence intervals here. So I'm going to mark that down as TC, and then we're going to use the sample standard deviations divided by the square root of the sample size here. Right. Now what we are looking at here, I'm going to draw a visual representations of what we are expecting here. So this part will be the T value. Now T distribution is also normally distributed. Drawn represent a T distributions curve, and then because we are dealing with 95% confidence interval, we are looking at this region here. So the region in between these two markers represent the probability of our 95% confidence intervals here. The left hand side tail, this part here, would represent the rejection zone, and then the critical value from the T distributions that we are trying to get will be here. This is the critical value. Okay. Now, in order to obtain this critical value, from the table that we are given from your data booklet, it shows us that this is a region that they are referring to whenever you are trying to read the information from the MF19 data booklet here. Now, because of this setup, so therefore we have to figure out this area. How big is this area that represent 95% confidence intervals here until here, right? Now for that, we know that because it's 95% confidence interval, so this region will represent 2.5%. Therefore, the green region here, the entire region, would represent 97.5%. Okay, so this information is quite important for us to extract that from the MF19 table. Other than that, other than knowing is 97.5%, because we are using student T distributions, therefore we must also identify the degree of freedom. So the degree of freedom here, I'm going to write down. Maybe I'll just write down df here. So degree of freedom is given by this formula, n minus 1. We know that the sample size is 9, so therefore our degree of freedom is an 8. Now on the table itself, this section represents the degree of freedom. Okay, so now we are ready to read the critical value that represent this 95% confidence intervals. Right? So first of all, is row number 8 here, degree of freedom 8. And then we're going to look under the column to see whether we have 97.5, which is 0.975 here, 0.975, so it's somewhere here. And then there you have it. Now that will be our critical value for these confidence intervals. Right? Okay, so I hope that is clear. Once we obtain this, we are going to write this one down here. Therefore, our critical value will be 2.306. All right. Now, once you are ready, we are going to finalize the evaluations of our confidence intervals for that represent 95% here. All right. Let's look at how we are going to evaluate this. Now, I'm going to rewrite these informations here. The confidence intervals for 95% is given by this x bar. I rewrite the formula one more time. Okay, now that should be the same as 91.6. The TC is a critical value by the sample standard deviation, which is I try to use the more accurate one, divided by square root of 9, in this case, which is a 3. Okay, so for this, let me try to tabulate that. Okay, yeah, maybe I'll try to tabulate it from here. It's much more easier, or maybe here will be good. Okay, just let me try this one out. So what we have here, 3.306 by 2.297 there. Okay, divided by 3. Okay, so I have myself 91.6 plus or minus 1.77 to be precise here. Okay, so I'm going to tabulate the first one, 0.6. Okay, so that would actually give me 89.8, and then the other one will be 93.37 here, right? Or approximately it's the same as 89.8, 93.4. Or if you like, you can write it down as 90 here, approximately to 93. Okay, if you want to round up according to the sample data that you have collected. Now that would represent the 95% confidence intervals that we have set up here, making assumptions the distribution is normally distributed. Now bear in mind, whenever it says normally distributed, it doesn't mean that we can use the standard normal distributions. You have to check whether the sample, whether the population standard deviation is given. If it is not given, then we'll have to use the T distributions in this case. Right? So I hope that is clear for the first part. Now the second part, the company regard its main competition as a railway service, which takes 95 minutes here. Okay. Now, does your confidence interval that we have obtained just now provide evidence that the journey time by the bus is different from that by the train there? So what they claim was the average journey time taken by the train is 95 minutes. So this is what they advertise. And then since this 95 minutes average fall outside of the regions of the confidence intervals. Therefore, we can conclude that we can conclude that there is an evidence, there is a significant evidence showing that the journey time taken by the railway service is different. So here I'm going to conclude that as a conclusion. So we are trying to make a decision right now using confidence interval. Since this 95 minutes that they claim fall outside of the regions of the confidence intervals, then we can conclude that we have sufficient evidence. We have sufficient. I would like to use the other term that Yoon Jae was using at this point is significant. So we have significant evidence that suggests that we have significant evidence to support that, or to suggest that to support that the journey time is different from the train. So here I take a bit of shortcut. Please excuse me for my sentence here, right? Now what I'm trying to say is we have significant evidence to support that the journey time taken by the bus is different from the journey time taken by the train, right? So I hope that is clear for this first part, how to make decision using confidence intervals. Now the next section that I'm going to show you is how to make decision using hypothesis testing. So using hypothesis test about the mean, about the population mean here. So second method. Right? Now I have indirectly saved the previous result for our reference. These are all the statistics that we can obtain from the sampling that they have carried out. And then this is a critical value that represents the 95% confidence intervals by using T distributions here. Right? Okay. Now from here, before we can actually apply hypothesis testing, we must set up the hypothesis statements. So based on the claim here, okay, we want to check whether the journey time by the train, the journey time by the bus is different from that by the train itself. So here we are going to write down our hypothesis statement. So hypothesis consists of the null hypothesis. So the null hypothesis we assume that we always make the assumptions the average journey time should be the same as 95 minutes. And then it's hypothesis testing. That is the counter examples to your null statement that must be not equal to in this case. Okay, so I hope that is clear. Now, next, we know that this sample size is quite small, and then sample standard deviations, the population standard deviation is not given. Therefore, we'll have to rely on the T distributions. So the model that we're going to use for these investigations will be T distributions function in this case. So I just use my own notation here. It is not a requirement in the exam to write this. So it's a T distributions with a degree of freedom. So we have calculated the degree of freedom, knowing that the sample size is 9. So the degree of freedom is actually equal to 8 here. And then this is a two-tailed test. Now that will be the alpha divided by 2 here, right? So I hope that is clear. That is the model, the T distribution model that we're going to use to analyze and then make a sound decision as to whether to support now or we fail to reject the null, right? Okay, so fail to reject the null, which means we indirectly support it, or we have sufficient or significant evidence to suggest that we can actually reject the null hypothesis, right? Okay, now for this, as usual, we're going to go through the test statistics process. Test statistics. Under the test statistics, we will be concentrating on all the evaluations related to the sample itself, especially the t test statistics value that we are going to compute here. So this is what they call as the observed um, test statistics, which we obtain from the sample. Now, in this case, the t test here, based on the formula. So the formula that we're using is this. Subtract off with the mean divided by here. Okay, right. Now that will be the formula we are going to use to calculate the observed test statistics in this case, right? Now for all the information that we obtain, we're going to write this one down as 91.6, subtract off with the mean, which is 95, divided by the standard deviations, that the sample standard deviations, which is 2.297 over the square root of 9, which is a 3 here. Okay, now just let me try to tabulate this, and then let's see what do we have here. Okay. Okay, sorry about that. Just give me a moment. Okay. All right. So what we have here would be negative 4.57 approximately. So negative 4.57. That will be our observed test statistics. Okay, in this case. So we're going to compare this observed test statistics with the theoretical critical value that we can obtain from the t distributions. All right. Now I'm going to draw the t distributions one more time. Okay. So this is t here. And then we have already found out the critical value from the previous exercise here. Now, because this is a two-tail test, don't forget that, because our alternative hypothesis is using not equal to, so it's a two-tail test. We are looking at two tail that consists of the rejection region, which is these two here. And then both of this area represent a total of 5%, which is actually 2.5% here. This one is 2.5% also. Okay. Now just recap the p-value that that represent the rejection region is 5% here. Right? Just for reference here, right? And then the critical value that we obtain from the theoretical t distribution table is over here, 306. This is 2.306 here. Okay. Now what we are trying to compare is with this observed test statistics value, is this critical value, is this observed test statistics value for within the rejection region. Okay, I might want to make a remark here. Both of these rejection region. Okay, this one is also rejection region. All right. So now from here, we notice that this is negative 4.57, which actually fall within that rejection zone or rejection region here. So we notice that this value here is actually negative 4.57, which is actually in the rejection region. Therefore, we have a significant evidence to support that we can actually reject. So here we are going to reject our null hypothesis, which is equal to 95 minutes here. So we're going to reject this And then finally, you have to make conclusions based on this context. Because we are rejecting this, therefore, we are indirectly supporting our alternative hypothesis. Therefore, we can conclude that the journey time we have sufficient evidence to support, to suggest, in this case, we use a different term to suggest that the journey time by the bus is different from that by the train. Okay, so I hope that is clear. We can actually make decisions using both of these methods, either by using confidence intervals or by using hypothesis testing. So I hope this will be a good revisions for all of you. Stay tuned for more sections under this hypothesis testing. All right, thank you very much.